Hi everybody. If you've been watching my channel, you have seen that I've repaired this frequency counter a while ago. And in a recent video, I have connected to a frequency counter FR4 that I'm working on to a module of that frequency counter. And due a component failure, I have fed it to the instrument 180 volts on input A. And I had anything wrong. The AC mode was enabled, so I was supposing that nothing could have been caused to the instrument. Well, today I have just switched it on, and this is what it does. Just barely glows those LEDs, no display, nothing. So I'm afraid that I've really damaged the input. So the first thing that I want to do, I was already opened it. I want to remove those two ribbon cable plugs and see if the input section here is disconnected to the rest of the instrument. The display will comes up, and this will tell us that we have a short circuit here. So hopefully it's not the case. Okay, I have removed both of the plugs. Let's see. Nothing. So we might have a power supply problem. I have checked all those 4 fuses that are here. They are fine. So what we have here, I have reconnected the input board. So if I plug the power cord, we have the standby light. So there is some activity. And if I switch on, we have seen barely here, we don't have any display, and the fan is spinning. So it seems that the problem is related to the digital power supply, which I suppose is the 5 volt. So let me try to read it. Let me move this back a bit and see if I can measure that. Since in the PCB there is stamped, and indeed we have 0.5 volt. So it's missing the plus 5. Let's check if we have some short circuit over there. Let me power off, remove the power cord, place the meter on ohm, and see. We have 150 ohm. So we don't have any short circuit. Seems that the 5 volt rail is down. So there might be a problem with the power supply itself. Let me grab the schematic and see if we can find the culprit. If we look at the schematic, we clearly see that the 5 volt generation it's through this regulator, which is in the back panel as stated here, which is right this one. And so the first step that I want to do is to check if at the collector we have some voltage that is over the 5 volts, maybe 7 or 8 volts, and clearly it's passing through this relay, which is activated from power switch, and the fan it is working, which is right here. So it means that this relay must be operative. So let's see if this voltage across here, it's present, and we will go from there. So I'm going to measure right at the regulator collector, which is here, and 0.6 volt for sure are not enough. So we must check at F1, which is almost not visible from here. Let's see this. 24, 26, 11. I'm checking on both sides, and for some wrong connection. What we have here, minus 11. Yeah, we have a bit of drop here. Maybe we have a bad. Oh, it might be that we have an additional fuse in the back, because 5 amp, I'm not seeing any fuse like that. Let me check in the back. Well, I'm actually wrong. F1 is right here. Let me lift up a bit this camera so you can see. So F1 is right here, and I'm having 12 volts, but I don't have any voltage on the collector. That is really weird. Should it be? Oh yeah, really? Unbelievable. Just the relay, it was making bad contact. So look, very simple thing can kill your instrument. So let me remove it, clean with some contact cleaner, and test again. I'm not sure that you can see it, but there is some tarnishing on those two pins, and I believe that is the problem that we had with the bad contact. So let's clean it up. Well, that's the best we can have. Tarnishing is not completely gone, but I think we can test in the instrument and see if it works. Okay. Yeah, still bad contact. Need to be improved a bit. Well, I have cleaned it again, and it seems that now it's more reliable. So I think that it's fixed. Okay, now that I'm relaxed that I didn't fry the input channel, I want to talk about a comment that I received in the previous video where I have adjusted this instrument. The comment indeed was talking about two major things. The revision of the instrument, there is an update, and the component replacement to increase the stability in readings. Both of those updates are, on my opinion, should be performed, I believe. The firmware, the way to see if we have firmware 1.0 or 1.1, which is the update revision, it's just by reading during the power on onto the address and 00. As we can see, we don't have any dot. In case that the instrument would be equipped with firmware 1.1, there will be a dot, as stated in this addendum to the manual. The firmware is a very good improvement, and there are a lot of functions that will be upgraded with this firmware. By the way that the instrument works needs a very old type of ROM, which is still available, by the way. But the problem is the programming. To program those EPROMs or ROMs, I should have said, need a very old programmer which is capable to burn the components up to 25 volts, and modern programmers can't do that. So unfortunately, I don't have in my hand in this moment of time such instruments, such a device. So I must skip this improvement to a later date when I will have in my hand those devices. And about the stability, the capacitor in question is C36 in A4, which is right this component here. This is a tantalum capacitor, 10 microfarad, the original one. It seems that increasing the capacity to 22 microfarad, we can improve the gate time and therefore the gate stability. So let's do this modification, since it's a very simple, and we can see the difference. Before to replace the capacitor, I want to check how it behaves with the standard one. So clearly, dropping down the speed, we increase the sensibility, and yeah, if I drop down, as you can see, it shut off the last digits. Now this is how it behaves now. So let's replace it and see if we can improve a bit. We are seeing jumping the last two digits, or three, I have to say. And indeed, if I drop down, well, it seems that to move last two digits. So let's see if we can improve it. The capacitor is replaced, right? This one yellow, and indeed has dramatically improved the reading here, and it's very more stable, and the change here, it's very minor, relevant. I'm having 100 kilohertz, so here we are in the millihertz range. So this is 1 millihertz, if I'm not mistaken, and it's jumping just few millihertz, 2-3 millihertz, which is very impressive. So this is hundreds of nanohertz, again, if I'm not mistaken. So yeah, should be like that. These are kilohertz, hertz, millihertz, nanohertz. That is very impressive. This instrument is beautiful. I don't have any more modern instrument that is capable to go so down in frequency. Very nice frequency counter. And so, thanks, David. Your comment, it was really spot on the target. Improvement done. So that's it for this video. I hope you have enjoyed it, and see you soon.